Hey guys, in this video we're going to be working on the basic integrals that deal with trig functions. So before we do that, I just want to remind you how I do the derivatives of trigs, and then we can look at the right side of the chart to figure out the integrals, okay? So the way that we do it is we first line it up with sine, cosine, tangent, and then the reciprocal of tangent is cotangent. The reciprocal of cosine is secant. The reciprocal of sine is cosecant. You're going to go ahead and you're going to plug in a positive, negative, positive, negative, positive, negative. So anything that has the letter C is a negative. Sine and cosine are the weakest, so they get each other. So sine gets cosine, cosine gets sine. Tangent and cotangent are powerful, so they get powers. This one will get secant squared. This one will get cosecant squared. Okay, secant, cosecant, they're not weak and they're not powerful, so they get themselves and they get someone else. Well, secant always goes with tangent and cosecant always goes with cotangent, so you need to memorize those. And just for fun, e to the x is e to the x. Okay, so now that we have this, I'm going to also remind you about the three Pythagorean identities. Okay, so I just want to point out one quick thing. Here, there's a square. Here, there's a square. So that means that we can find the integral of secant squared. Well, that integral is just this person. We can find the integral of cosecant squared. Well, that's negative cotangent. Anything else that has a squared, because it's not exactly on this side, you're going to have to think of an identity. So you're going to have to use these. Okay, so the only ones we know right now are secant squared and cosecant squared, which is great because if you're asked for tan squared, you just have to minus 1. If you're asked for cotangent squared, you just have to minus 1 and then integrate them. So let's go through these problems really quickly. Okay, from the last video, we know that pi is about 3. 3 squared is 9. 9 times 3 is 27. So this is approximately 27, a little bit more. What's the integral of 27 with respect to y? 27y. So what's the integral of 3 pi squared with respect to y? 3y squared y plus c. Great. In the next problem, if there's no number but a 1 in the numerator, it's sometimes written as dx over 3x squared. But this is identical to writing 1 over 3x squared times dx. Leave the 1/3 out because it's a product. And you could just bring the x squared up because remember, we can't integrate quotients. Add 1 and then divide. So when you add 1, you get negative 1, divide by negative 1. Plus c. So this is going to be a negative third. And because the x has a negative 1, you're going to bring that right back down. And that's your final answer. Okay? And this person here, in this problem right there, number 13, it's a quotient. You can't do quotients. So what you're going to have to do is divide, but we can't divide either because we could only divide by if there's a monomial in the denominator. That's from the last video. So what do? Well, if you remember basic algebra, we factor x plus 4, x minus 4 over x plus 4. So now we cross this off. And so number 13 is just basically what is x minus 4? What is the integral of x minus 4? X squared over 2 minus 4x to the first over 1 plus c. So you had to factor there. Remind yourself that you cannot integrate quotients, okay? This is a quotient. How do we bring this? Well, that's going to be t to the 1/3. So because it's on the bottom, I'm going to go t to the negative 1/3. It's with respect to t. Guys, do not forget this. You can leave the 3 on the outside, okay? So I'm just going to erase this. So how do we integrate this? Well, You're going to add 1 to negative a third. You get 2/3. We're going to divide by 2/3, which means multiply by 3 over 2 plus c. The 3's don't cancel out. They're next to each other, so you multiply them. 9/2 t to the 2/3 plus c. If you want to write it in a radical form, numerators stay on the inside. Okay? You can pause the video if I'm going too fast. Okay. Number 15, you're going to have to rewrite this person as x to the 1/2. This person's x to the 1/2, but because that person's on the bottom, you got to bring it up to be a negative a half. Okay? So let's do that. So we have to rewrite this 1/2 x to the positive 1/2 because it's in the numerator, x to the negative 1/2 because it's in the denominator. We're going to put parentheses around this because we want the dx to impact both pieces. We're going to add 1. You're going to get 3/2 and then put 2/3 here. We're going to get positive a half, right? Because negative a half plus 1 is positive a half. And then we're going to put 2 over 1 here. These two cancel out. You get 1/3 x to the 3/2 minus 6 x to the 1/2 plus c. For those who want to go a little bit above and beyond, remember 3/2 is 1 1/2. Remember, a half means a square root, so you can actually go there and go like this. So I can save some time. So that's really your final, but this absolutely is correct. So take your time and watch the video again. Okay, here's our last few problems. I'm going to just take a look at my right side and say, remember, 2 is a number, 3 is a number. And ask yourself, who gives me sine? So let me go here. I'm going to go here. Well, sine, negative sine is cosine. But because there's no negative, I have to compensate by putting the negative there. So this is going to be negative 2 cosine x minus 3. So leave the negative 3, it's just a constant or a coefficient. So we're going to just leave that. And who gives you positive cosine? Don't worry about this minus. Who gives you positive cosine? Positive cosine, positive sine. That's it. Okay. What's the integral of sine squared and cosine squared? Well, then sine squared and cosine squared are not here. So now they're nowhere here. Now you go here and you say, oh, that's an identity. It's just 1. So first thing I'm going to do is I'm going to exchange it for 1. That's not your answer. You have not integrated yet. You just replaced it. Now your answer is going to be x plus c. Okay? Here, when cosine is in the denominator, you can write it as secant in the numerator because secant x is equal to 1 over cosine x. Because this is a square, it's secant squared x. Now all you guys have to do is take a look at your chart. Who gives me secant squared x? Well, that's a perfect tan. Who gives me secant x tan x? That's a perfect secant x. They're perfect. They're right on the right side of that chart. So you're good. So that's done. Here, I'm going to write this as 1 over cosine theta times sine theta over cosine theta. 1 over cosine, again, is secant theta. Sine over cosine is tan theta. Well, guys, this is right on your right side. Who gives you secant theta tan theta? Just plain old secant theta. So I hope that makes sense. The reason why we can do this, everyone, is because if you were going to rewrite this back, 1 times sine is sine, cosine times cosine is cosine squared. And our final problem of this video is cotangent squared x. Well, cotangent squared x is not on the right side. and it's a square. So I said, if it's not on the right side and it's a square, then we're gonna have to go look for one of those identities. So the identity that we have here is here. So I'm gonna minus 1. Okay, so I'm gonna replace that, and then I'm gonna say, who gives me cosecant squared theta? Well, cosecant squared theta is this person here. Because I don't have a negative in front, I'm gonna have to compensate. So that's negative cotangent theta. And who gives me 1 with respect to theta? 1 theta. So that's your final answer. So I hope the video was helpful. In our next video, we will be doing U substitute. Okay, so come back for that video.